So the objective function says that we have to minimize this function over here, c1x1 plus c2x2. Let's do something silly. Let's say pick a very, very negative number, for example, minus v, and we want to see if we can have the value minus v for this function. So imagine that I am running a program that is start from, say, quote unquote, minus infinity. So I start from minus infinity here, and I slowly increase to see where I can, with the first time that this point is satisfied. So obviously if I can set this guy to minus infinity, then that's obviously the minimum. But now let's say I'm slightly increasing this, okay? Just to get an intuition what this means. So let's say this is a particular value minus v. What does this represent? c1 x1 plus c2 x2 equals minus v. Well, that's just an equation of a line, right? So let's say this line. And let's assume that this minus v is too small, that there is no feasible point. In other words, that's not the answer. The answer should be larger than minus v. If I want this function to be as small as minus v, this line does not intersect the feasible region, so therefore the answer is not minus v. So I try something bigger. So in other words, in my algorithm, I'm trying to go over all the real numbers that are bigger than minus v and trying to find the first one where this inequality is satisfied. So I try minus v plus epsilon, then minus v plus 2 epsilon, and etc. I mean, this is not a real algorithm. This is just for us to understand. So let's see what do these lines mean. So each one of them is a line. So this is a line, this is a line, and this is a line. What is it that we can observe about these lines? The observation that we can make is that all of them have the same slope, because these constants don't change. The slope of all of these lines is essentially c1 divided by c2, because x2 is my y coordinate and x1 is my x coordinate, right? So therefore, as I'm increasing this epsilon here, I'm just constantly drawing lines parallel to this original line that I started with. But what is the effect of moving this epsilon? It essentially moves this line in a particular direction, let's say in this direction. So therefore, the objective function can be understood as a direction. And essentially it is the first point of the feasible region that is hit by a line moving along a direction. So you draw this line and then you move it along this direction, and the first point of the feasible region that you hit is going to be the answer that minimizes this. And the proof is actually not difficult at all. It follows from the intuition that we covered, because since this is the feasible, this is the first point hit by this ray, it follows that if I change t to t minus epsilon, then that does not hit the feasible region by definition, okay, or by the property that we just covered. So therefore, we can see that that's the way to model objective function. So now we have an understanding of what constraints mean. So the constraints give us the feasible region, and the objective function gives us the direction. And the vertex of the feasible region we want to find is the first vertex of the feasible region hit by a line moving along that direction.